In this video, we will learn how to solve arithmetic series. But before that, let us define first what are arithmetic series. An arithmetic series is the sum of the terms of an arithmetic sequence. The formula in finding the sum of the terms of an arithmetic sequence is denoted by S sub n is equal to 1/2 of n times the quantity a sub 1 plus a sub n, or S sub n is equal to 1/2 of n times the quantity twice the a sub 1 plus the quantity n minus 1 times d. To find the formula for the sum S sub n, the first n terms of an arithmetic sequence, we can write out the terms as S sub n is equal to a sub 1, which is the first term, plus a sub 1 plus d, which is the second term, plus a sub 1 plus 2d, which is the third term, and plus and so on until to the last term. This can be written in reverse as S sub n is equal to a sub n, which is the last term, plus a sub n minus d, which is the last second term, plus a sub n minus 2d, which is the last third term, plus and so on until to the first term. Now, add the corresponding terms of these two expressions for S sub n to get 2S sub n is equal to a sub 1 plus a sub n plus a sub 1 plus a sub n plus a sub 1 plus a sub n plus and so on plus a sub 1 plus a sub n. The right-hand side of this expression contains n terms, each equal to a sub 1 plus a sub n. So, 2s sub n is equal to n times the quantity a sub 1 plus a sub n. It can be simplified as s sub n is equal to n over 2 times the quantity a sub 1 plus a sub n. It is sometimes useful to express the sum of an arithmetic sequence S sub n in terms of a sub 1 and b, the quantities that define the sequences. We can do this as follows, since S sub n is equal to 1/2 of n times the quantity a sub 1 plus a sub n, and the n-term formula a sub n is equal to a sub 1 plus the quantity n minus 1 times d. By substituting the expression for a sub n into the expression for s sub n, we obtain s sub n is equal to n over 2 times a sub 1 plus the quantity a sub 1 plus n minus 1 times d. It can be simplified as s sub n is equal to n over 2 times the quantity twice a sub 1 plus the quantity n minus 1 times d. Therefore, the sum of an arithmetic sequence S sub n can be found using the following formula, depending on the available information. S sub n is equal to n over 2 times the quantity a sub 1 plus a sub n, or S sub n is equal to n over 2 times 2a sub 1 plus the quantity n minus 1 times d, where S sub n is the sum of the terms, a sub 1 is the first term, a sub n is the last term, n is the number of terms, and d is the common difference. There are 3 steps to follow in solving the sum of the terms of an arithmetic sequence. First step, identify the first term, the last term precision, and the common difference of an arithmetic sequence. Second step, use the formula in finding the sum of the first n terms of an arithmetic sequence. Third step, substitute the values and calculate for the sum. Illustrative examples. Example number 1. Find the sum of the arithmetic sequence 13 plus 21 plus 29 plus 37 plus and so on until 165. In finding the sum of this arithmetic sequence, first step, identify the given values of the arithmetic sequence. So we let a sub 1, first term, is equal to 13. A sub n, the last term, is equal to 165. D is equal to 8. We get 8 by subtracting the first term from the second term. And n is unknown. Since the term precision n is unknown, solve for n first using the n-term formula. The n-term formula is a sub n is equal to a sub 1 plus the quantity n minus 1 times d. Next, substitute the values for a sub n, a sub 1, and d. A sub n is 165 is equal to a sub 1 is 13 plus the quantity n minus 1 times d is 8. Distribute 8 to the quantity n minus 1, it becomes 165 is equal to 13 plus 8n minus 8. Combine like terms, it becomes 165 is equal to 8n plus 5. Applying the additive inverse property of equality, it becomes 8n is equal to 160. Simplify, it becomes n is equal to 20. We can now solve for the sum of the terms of the arithmetic sequence. To solve for the sum, we use the formula for s sub n, where s sub n is equal to n over 2 times the quantity a sub 1 plus a sub n. Next, substitute the values. S sub 20 is equal to 20 over 2 times the quantity 13 plus 165. Simplify, it becomes S sub 20 is equal to 10 times 178. So the answer is S sub 20 is equal to 1780. Therefore, the sum of the first 20 terms of the given arithmetic sequence is 1780. Example number 2. Find the sum of the first 15 terms of the arithmetic sequence 4, 10, 16, 22, and so on. To solve the sum of the first 15 terms of this arithmetic sequence, we need to apply the steps. First step, identify the given values of the arithmetic sequence. So we left a sub 1, first term, is equal to 4. The common difference is 6. We get 6 by subtracting the first term from the second term. N is equal to 15. Since the given values are a sub 1, n, and d, we use the following formula. S sub n is equal to n over 2 times 2 a sub 1 plus the quantity n minus 1 d. Next step, substitute the values. S sub 15 is equal to 15 over 2 times 2 times 4 plus 15 minus 1 times 6. Next, operate for the sum. It becomes S sub 15 is equal to 15 over 2 times 8 plus 14 times 6. Simplify, it becomes S sub 15 is equal to 15 over 2 times 8 plus 84. So the sum of 84 plus 8, it becomes A sub 15 is equal to 15 over 2 times 92. So the final answer is S sub 15 is equal to 690. Therefore, the sum of the first 15 terms of the arithmetic sequence is 690. Sample number 3. Every week, Mr. Santos increases his profit from selling cell phones by 250 pesos. His profit during the first week is 2,750 pesos. How much will his total profit on the 12th week? To solve for his total profit on the 12th week, we need to apply the steps. First step, identify the given values of the arithmetic sequence. We let a sub 1 is equal to 2,750, which is the profit of Mr. Santos during the first week. D is equal to 250, and N, since the given values are a sub 1, n, and d, we use the following formula. S sub n is equal to n over 2 times 2 a sub 1 plus quantity n minus 1 times d. Next step, substitute the values. S sub 12 is equal to 12 over 2 times 2 times 2,750 plus 12 minus 1 times 250. Operate for the sum. It becomes S sub 12 is equal to 6 times 5,500 plus 11 times 250. Simplify, it becomes S sub 12 is equal to 6 times 5,500 plus 2,750. Then, S sub 12 is equal to 6 times 8,250. So for the final answer, S sub 12 is equal to 49,500. Therefore, the total profit of Mr. Santos on the 12th week is 49,500 pesos. To test your understanding, kindly answer the following problems. Prepared by Marjorie Q. Jano. Thank you for watching.